For problem 4.1, determine the internal normal force, shear force, and bending moment. So we are looking for normal force, shear force, bending moment at sections C and D. Here is point C, here is point D. Remember, assume support A is pin, support B is roller. So our problem looks like this. This one is roller. That one is hinge. We have one concentrated load here, 6 kilonewton, and concentrated moment 20 kilonewton meter. First step, we need to calculate our reaction. This support is A, this one is B. Hinge, we have two reactions, XA, YA. This one is roller, so we have one reaction, YB. 3 equilibrium equation, summation f of x equals 0. So XA equals 0. Summation moment at A equals 0. Assume this direction is positive. We have 6 times 2. We have positive 20. Negative YB times total distance 6 equals 0. The only unknown in this equation, YB equal 5.33 kilonewton. So your reaction here, 5.33, XA is 0. The third equilibrium equation, summation f of y equals 0. We have YA negative 6, positive YB equals 0. The only unknown here is YA, where YB is 5.33. So YA as a reaction equal 0.67 kilonewton. This reaction is 0.67. This is the first step. First step to calculate your reaction. The second step, where is the first point? C. Make your cut at C and decide which direction I'm going to use. Actually, I'm going to use the most easy one, which is the smallest one. So I'm looking for my cross section from left. What do you have in your left? Actually, we have something looks like this. Here we have hinge, has two reaction, YA 0.67, XA 0, and here is my cross section. At your section, we will assume the internal force, normal, shear, and moment in the positive direction. Positive direction for normal is tension, N at C. For shear, make this member rotate clockwise, so VC. Your moment made or makes your member to smile, so MC. Then you need to reapply your equilibrium equation for this part. Actually, summation f of x equals 0. That means your normal at C is 0. Summation f of y equals 0. We have 0.67. Negative VC equals 0. So shear at C is 0.67 kilonewton. Summation moment, I will take moment at point C. Summation moment at C equals 0. We have MC, we have negative 0.67. Remember that distance is 1 meter. So 0.67 times 1 meter, that's it, equals 0. So MC equal 0.67 kilonewton meter. The second cross section at point D. So I will make another cut here, and you need to decide which direction I'm going to use. We have two options, this option or that option. Actually, I will use the right option. It's very simple. So what do you have in your right? Actually, here is my cross section. At this location, we have roller support. We have vertical reaction 5.33. Your internal force, normal at D is tension. Your shear will be up, VD. Your moment make your member to smile, MD. That distance is 2 meters. Reapply your equilibrium equation. Summation f of x equals 0. That means ND is 0. Summation forces in y direction equals 0. We have V at D positive. We have positive 5.33 equals 0. So your shear will be negative 0.533 kilonewton. Negative means your assumption not correct. Should be down. Summation moment at D equals 0. Here is point D. So we have MD. ND and VD will be cancelled when taking moment at point D. Also, we have negative 5.33 times 2 equals 0. The only unknown is MD. Your moment will be yeah, I forgot something here. Yes, I forgot we have 20 kilonewton meter as external concentrated moment. So I need to add here positive 20 equals 0. Yeah, that's good. So MD will be negative 9.33 kilonewton meter. Remember, from this right, we have vertical reaction at B and concentrated moment. So the internal forces at section D, N is 0, shear is 5.33 down, your moment is 9.33, should be counterclockwise. For problem 4.6, we need to determine the internal normal force, shear force, and bending moment at section C and D. Assume A is roller and B is hinge. Okay, so the free body diagram for this beam looks like this. We have here hinge at this location, and at that location it's roller. Hinge means we have two reactions, By and XB. Sorry, can assume it YB, and we have here YA. We have external non-uniform distributed load, looks like this. Your value 4 kilonewton per meter. That distance 3 meter, and that distance 3 meter. So your equivalent load will looks like this. Your value 1/2 time total distance, which is 6, time your height here 4, your value will be 12 kilonewton. To calculate your reaction, summation f of x equals 0, xb will be 0, no external horizontal force. Summation moment at B equals 0, assume this direction is positive, so we have 12 time, remember the location of this equivalent force at 1/3 from this side and 2/3 from the other side. The total distance is 6, 1/3 is 2 meters. So your distance will be 2 minus YA time distance 3 equals 0. Only unknown here is YA. Your value of YA equal 8 kilonewton. So my reaction here is 8. Summation f of y equals 0. We have YA negative 12 plus YB equals 0. YA was 8. That means YB will be 4 kilonewton. Perfect. The second step, made your cut. But remember, I need to show you something. Can you tell me what is the value of the distributed load at section C? What is the value of the distributed load at section D? We need to do a triangle similarity between this triangle and the total triangle. What we have? We have here y, w at c, this value is w at d. For this little triangle with the total triangle, so we are going to say 1.5, which is this distance, related to the similar distance, which is the total distance 6, equal that little height, which is w at c, divided by the similar height here, which is 4. We can say your w will be 4 times 1.5 divided 6 will be 1 kilonewton per meter. Same thing, this little, not little triangle, but this triangle, the total one or partial one with the total one. So we are going to say that distance, which is 4.5 divided by the total distance 6, equal this height, which is WD, divided by the total height 4. Your value of WD will be 3 kilonewton per meter. Right now, keep going and make your cut. First cut at point C. We are going to make cut here, and I'm going to use the left part. It's very easy. What do you have in your left? Actually, we have, here is my section, normal at C, extension, your shear will be down, your moment make your member smile, MC and VC. What else? Actually, we have very little triangle, looks like this. Your value here of the triangle is 1 kilonewton per meter. Remember that distance is 1.5 meter. The equivalent force for this little triangle, the value is 1/2 times 1.5 times 1 equal 0.75 kilonewton. At distance 1/3 from this side, which is 0.5. Apply your equilibrium equation, summation f of x equals 0. That means NC is 0, no horizontal force. Summation f of y equals 0. Actually, we have negative 0.75. We have negative VC equals 0. Your value of this VC equal negative 0.75 kilonewton. Summation moment at C equals 0 at this location. So we have MC is positive. We have positive also 0.75, the equivalent force for the distributed load, time distance, which is 1/3. The total distance is 0.5 meter equals 0. The only unknown here is MC will be negative 0.375 kilonewton meter. There is the internal forces at the first cross section C. The second cross section is at D. Where is your D? Looks like here. So actually I will make cut here at D, and I don't like trapezoidal, so I will look to my left also. What do you have on your left? I have all of this. So left of cross section D looks like this. Remember, here is roller. That distance for section D is 1.5, and that section 3 meter. We have at C here normal force, shear, and moment make your member to smile. What else? Actually, we have triangle distributed load, looks like this. And if you go back, your value here was 3. So your value is 3 kilonewton per meter. Your equivalent force will be 1/2 time total base, which is 4.5, time height 3, your value will be 6.75. Your location at 1/3 from the site. The total distance is 4.5. So 1/3 from 4.5 is 1.5. So the location of this equivalent force at the same location of the roller. Okay, keep going. Summation f of x equals 0. Also, normal force at C is 0. Summation forces in y equals 0. Oh, I forgot something here. We have reaction at this roller 8 kilonewton. So we have in y direction 8, we have negative 6.75. We have negative VC equals 0. Your value of shear equal 1.25 kilonewton. By taking moment at section C, we have MC, NC and VC will be cancelled. We have also positive 6.75 times distance 1.5. We have negative 8 times same distance 1.5 equals 0. The only unknown is your moment at C equal positive 1.875 kilonewton per meter. So the internal forces at C, normal is 0, your shear 1.25 and your moment 1.875. For problem 427, draw shear and moment diagram. The first step in any problem is to calculate your reaction. Actually, at A, it's hinge, so we have YA and XA. At B, it's roller, so we have YB. The equivalent force for your distributed load at the middle, your value is 15 times 400 equal 6,000 pounds. Summation forces in X direction equals 0, XA is 0. Summation moment at A equals 0, and I'm going to assume this direction is positive. So we have 600 times 7.5 plus 600 pound-feet in the same direction, which is clockwise, minus YB time total distance 15 equals 0. The only unknown is YB. YB will be 40 pound, 340 pound. So this value 340 pound. Summation f of y equals 0. We have YA negative 600. We have YB positive equals 0. YB was calculated 3040. So YA will be 2,960 pound. I'm sorry, I forgot. YB is 3040, not 340. I'm sorry, 3000. Okay, YA is 2,960. First step to draw your shear force diagram. We are going to draw lines, vertical lines at each load, support, and everything in your beam. Then draw line for shear and one more line for moment. For shear, I'm going to start from my left. I'm standing here. My left is here. What do you have in your left? Actually, I have YA goes up. So please go up 2,960 reaction YA. I need to go constant, or I need to go inside your beam. We have uniform distributed load, so I will go constant dotted till I found the equivalent concentrated load or the equivalent load of the distributed load, which is 6,000. So go down 6,000. Remember this drop 6,000. So I'm here at 2,960. Go down 6,000. So I'm reaching 3,040. Keep going till you found the last reaction YB goes up, so I will close to 0. From the first point to the end point of the distributed load, I'm going to draw line. Why line? Because your load is constant. Integration of constant is linear relationship, so your shear will be linear. I'm interested, where is this point? This point called point of zero shear. This point is important for me because at this point is the maximum bending moment value. So I'm not sure where is this point. This point not at the middle. Why? Because this value does not equal this one. So I'm going to assume this one at distance x. That means the other distance will be 15 minus x. Okay, we have triangle similarity. We can say x divided by the similar distance 15 minus x equal this height 2960 divided by the similar one, which is 3040. So the only unknown here is your distance x will be 7.4 feet. So this distance is 7.4. That means this distance will be 7.6 feet. Okay, to draw your bending moment diagram, I'm going to start from my left also. Actually, on my left, it's free end, and this end has concentrated moment. On my left, I have concentrated moment clockwise, so it's positive 600. The next point will be at this point where your shear is 0. I'm interested for this point because at this point we have maximum bending moment. To calculate any value of moment, so moment at this location equal to the previous value, which is 600, plus area of shear in between these 2 points. What do you have of area of shear? Actually, we have triangle, positive area, 1/2 times 7.4 times 2960. So this is the important why I'm interested with what is this distance. Where is the point of zero shear? Your value will be 11,552 pound feet. So this value here will be positive 11,552. What is the value at the beam end? Actually, we have two options here. This point at the beam end is free point, nothing else. We don't have any concentrated moment. That means your moment here will be 0. One more evidence. If you are looking for moment at this location, okay, your moment at this location equal to previous value, which is 11,552 positive, plus area of shear in between. What do you have in between this point and that point? Actually, we have this area of shear, which is negative. So we have area negative 1/2 time your distance, the base distance 7.6. The height is 3040. Your value will be 0. So my value here is 0, 11,552, 600. So draw curve between this point and that point, this point and that point. This curve from second degree. Why? Remember, your moment is integration of your shear. Your shear is linear relationship. That means your moment is parabola from second degree. Positive, and you can make some from here and here. For problem 442, Actually, we are looking to draw normal, shear, and moment diagrams for the shown frame. A is fixed, B is pin connection, and C it's roller. So we are before calculating your reaction, actually we are going to make cut at this connection. It's pin connection. We prefer to do cut at this connection first before starting to calculate any reaction. To draw your free body diagram after your cut, we have two members. At A, it's fixed, so we have free reaction, YA, XA, and MA. At C, it's roller, so we have one reaction, YC. Your external force at this location, we have 20 kb. Inclined force, we have horizontal uniform distributed load with value 0.5 kb per foot. Kb per foot. And we did cut at this point, which is pin connection. So we have two reactions actually, one horizontal, one vertical, XB and YB. Same value, but in opposite direction here. Before starting doing any equilibrium equation, we have inclined force. So assume this angle theta. So the horizontal component will be 20 cosine theta. The vertical component will be 20 sine theta. Remember, we have triangle here, and we assume this angle theta. That means this little angle is theta also. So sine theta will be the opposite, 3 divided by your hypotenuse, 5. Cosine theta will be 4 divided 5. So this value, cosine theta, 4 divided 5 times 20 is 16. 20 sine theta will be 12. Now we can apply equilibrium equation for each part. I'm going to start with this part first. Summation f of x equals 0. We have xb and positive 16 equals 0. That means xb is negative 16. Negative means your assumption is correct. I assumed it on my right. No, it should be on the left. Keep everything the same. Don't change anything until we start to draw. Okay, summation moment at B equals 0. I'm here at B and assume this direction is positive. You can assume what you want. So we have 12. Actually, YB and XB will be cancelled. So we have 12 times horizontal distance 6, negative YC times horizontal distance 12 equals 0. The only unknown is YC will be 6 kb. So this value is 6. Summation f of y equals 0. YB will be 6. So actually we have two options here right now. We can change our direction. So we can cancel this direction and say it looks like this and your value is positive 16. Or you can keep your direction and keep your sign, which is negative. I prefer to change your direction and use the positive value. So my direction here will be like this, 16. And your value YB is 6. Right now, I am here on this part. We have equivalent force here for the distributed load. 0.5 times 8 is 4 kip. So if you apply summation f of x equals 0, xa negative xa positive 4 positive 16 equals 0. So xa will be 20 kip. Summation f of y equals 0. We have ya negative yb equals 0. So ya will be 6. If we apply moment at a, summation ma equals 0. So 4 times vertical distance 4 plus 16 times vertical total distance 8 minus ma equals 0. Your value of ma will be 144. So I am done with my reaction, and at the same time I am done with my free body diagram for each member. So right now we are going to draw 3. We can make it here. 1 for normal, 1 for shear, and 1 for moment. Let's start with the normal force. For the vertical member, we have forces parallel to the member, which is YA 6 and YB 6, pushing this member, so it's in compression. So we have here 6, 6, negative. I am done with normal force for the vertical member. For the horizontal one, actually, the only part of this member in between two tension force is this part only. Between 16 here and 16 here, want to pull this part of member. So on this part only, we have tension positive 16 and 16. The rest of this member, 0 normal force. You can ask me a question, a good question. Why this 16 goes to this part of member, not for this part? The answer is very simple. If there is a part of 16 goes to this part, what will be here? Nothing. That means no normal force on this part of member. For shear, I am here and I am here. I will start for this member from my left based on my position. At left, I have vertical force goes up 20. So I will go up 20. Keep going, but dotted till you found your equivalent force. 4 goes down. So I will go down 4 till 16. Keep going till at the end of the member you hit 16, goes down, so it will close to 0. From this point 16 to this point 20, I'm going to draw linear relationship. It's positive. For the horizontal member, based on my position, here is my left, I have YB goes up 6. Keep going constant till you found 12. The vertical component 12 goes down, so I will go down 12 until 6. Keep going till you found your reaction YC, which is 6, will close to 0. Negative, positive. For bending moment diagram, the vertical member on my left is free end. Free end with concentrated moment on my left. That moment is counterclockwise on left. That means it's negative 20. The other end of this member, there is no concentrated moment. That means your moment here is 0. The typical question I will draw parabola, but the question is, parabola looks like this or parabola looks like this? The answer is very simple. At this point, the tangent, the original position of your tangent is vertical, coincide with your member. But your shear has value 16, which is positive. Positive means your tangent will rotate counterclockwise. Looks like this. At this location, the original shape of the tangent is vertical, coincide with your member, but your value of shear is positive 20. So will rotate counterclockwise and steeper, because your value here is 16 and this value is 20, so 20 greater than 16, so steeper. So right now I'm going to draw parabola, tangent here and tangent here. So my parabola looks like this, negative, negative. For the second member, my value of moment here is 0, no concentrated moment. I'm looking for my value here at the concentrated load. Okay, we can calculate it using shear force diagram. Moment at this location equal to previous value, which is 0, plus area of shear in between. We have this area of shear between this point and that point. So we have positive 6 times horizontal distance, which is 6, equal 36 positive. So value here is 36. The last point here, we have two options to calculate this point. The first option, at this location, it's free end, your moment is 0. Or you can say moment here equal previous value, which is positive 36 plus area of shear in between. Actually, we have this area of shear, it's negative area, 6 times 6, so my value is 0. From this point to this point to this point, I will draw linear relationship because your shear in these locations is constant. So here is your normal, shear, and moment for the shown frame. For problem 4D, we are going to draw normal force, shear force, and bending moment diagram for the shown frame. A is rocker or roller. D is hinge or pin. So we have only one reaction at A, YA. We have two reactions at D, YD. Actually, we have more experience right now, so we will assume XD looks like this. The only horizontal force is 3, goes to left, so XD will be right. The equivalent force of the distributed load is 2 times 8, 16 kb. Apply your equilibrium equation, summation f of x equals 0. So xd minus 3 equals 0. Your value of xd will be 3 kb. Summation moment. We can take moment at D. Any point equals 0. Assume this direction counterclockwise is positive. So moment at D will cancel xd, yd, and 4 kb. So we have 3 times vertical distance 15 plus 16 equivalent load times this distance, which is 4 plus 4 is 8, minus your reaction YA times the total distance 12 equals 0. The only unknown is YA. Your value of YA would be 14.42 kb. So that reaction is 14.42. That reaction is 3. Summation f of y equals 0. We have YA negative 16, negative 4 plus YD equals 0. Your value of YA 14.42. The only unknown is YD equal 5.3. 5.58 kip. So that value is 5.58 kip. So the first step is your reaction. Second step, actually, I'm going to draw to divide this frame into members. So this connection, it's rigid connection, and that connection, it's rigid connection. So vertical member looks like this, horizontal member looks like this, and the other vertical member looks like this. Remember, we have one reaction here, 14.42. We have two reaction here, one vertical, 5.58, and one horizontal, which is 3 kip. We have uniform distributed load on this member. The equivalent value was 16. Actually, for these two concentrated load at this location, you have two options. The first option, you can put them on at this point, or the second option, you can put them at this location, as you like. Both of them works, 3 and 4. What else? What do you have else? At this rigid connection, which called B, we have XB, YB, and MB. This value will be the same, but in opposite direction on the other side of point B. So we have horizontal, vertical. This moment is clockwise, that moment is anti-clockwise. Same values, but in opposite direction. The same concept at this joint, because this joint C is rigid connection. So we have XC, YC, and MC. This value will be the same, YC, XC, and your moment MC. Okay, we need to reapply equilibrium equation on each part. Let's do it for the first vertical member on your left. If you see here summation f of x equals 0, actually xb will be 0. I'm looking for this member only. Summation f of y equals 0. We have vertical 14.42 up. That means yb will be down 14.42. If you take moment at this location B, you will get MB as 0. That means the vertical reaction here will be the same value but in opposite direction, 14.42. Horizontal reaction, which is 0, will be the same value here but in opposite direction, and your MB is the same. That's it. For the horizontal member, you can apply summation f of x equals 0. Actually, we don't have any horizontal force except xc, so xc is 0. Summation f of y equals 0. We have here 14.42. We have 16. We can figure out what is the value of yc. Your value of yc will be 1.58 kip. So this value is 1.58. Take moment at C. At C, take moment at C equals 0. You can figure out what is the value of MC. I'm looking only for this member, remember. So value of MC will be 45. So this value is 45 positive. That means my direction is correct. This value will be the same here. This moment 45. The horizontal reaction will be 0. The vertical reaction will be 1.58, same value but in opposite direction. I am done. I draw free body diagram for each member in my frame. So I'm going to draw 3 copies of my frame. One for shear, one for normal, one for shear, and one for moment. Let's start with normal. What do you think here? What normal force on this member? Normal force is the force that is parallel to your member. So my member is vertical. The force that is parallel is 14.42. Pushing or pulling your member, it's pushing. That means it's compression. So the vertical member on my left, has compression force, negative means compression, 14.42. And you can make some fun. The second member, what is the force which is parallel to this member? Actually, we have XC here, we have 0 here. That means no normal force on that member. Okay, 0. What else? That vertical member has parallel force 5.58 from the top. Actually, we have 4 and 1.58, so the total is 5.58 from up and from down. Pushing this member, that means it's a compression. That member is compression member, negative 5.58. I am done with my normal. To draw my shear, please come and stand under your member, but you and your member make 90 degrees. So I'm here, I am here, I am here. Let's start with the first member here. Where is your left based on your position? Actually, my left is here. Do you have any force perpendicular to your member at this location on your left? Nothing. So 0 shear here, nothing happened, nothing happened, nothing happened. So I don't have any shear on this member. Second member, this one, here is my left. On my left, I have 14.42. Remember, the force that makes shear must be perpendicular to your member. Okay, 14.42 up, so I will go up 14.42. Keep going. I found distributed load, so dotted until I found 16. Goes down, so go down. Go down 16, but dotted till you hit 1.58. Keep going till you finish your distributed load. From the start to the end, draw linear relationship. Why linear? Because your load is constant, your shear is linear relationship. Nothing here to go up or down, so keep going constant till you found your YC as a reaction. 1.58 goes up, so I will close to 0 here. Negative, positive. You can do some fun in your diagram. The last member based on my position, actually I will start from my left. My left is here. What do you have in your left? Actually in my left I have force 3 goes down related to my position. I am down here, down related to my member. So on my left I have 3 goes down. So go down 3, keep going constant, nothing, no change until I found another 3 goes up. So I will go up till I hit 0. So your value is 3, negative. Do some fun on your diagram. I am done with my shear. Okay, the same question. Do you think this point is important? Sure. This point is point of 0 shear. At this location, we have maximum moment, so this point is important. We can assume it at distance x. So right now we have something looks like this. This value is much 14.42. This value is 1.58. So I'm drawing line looks like this. And this point is 0 shear at distance x. Do you think what is the remaining distance? Actually, the total distance of this distributed load is 8. So this one is 8 minus x. Triangle similarity between this one and that one. We can say x divided by 8 minus x equal 14.42 divided by 1.58. So your distance x using your calculator will be 1.58 plus 14.42 divided by 14.42 times 8 inverse. Your distance is 7.2 meter. Is it meter or feet? I'm sorry, it's feet. So your unit is feet. So this distance is 7.2. That means that distance is 0.8. Okay. So this one is 0.8 and this one is 7.2. Your moment. For this member, this point is free end, no concentrated moment. The second point is free end, no concentrated moment. Actually, we have concentrated moment, but my value is 0. So here is 0 and here is 0, nothing in between. It's 0. That makes sense for me. Your shear is 0. Integration of 0 to two situations, two cases. Integration of 0 is 0 or integration of 0 is constant. In this case, it's 0. Okay. For the horizontal member, at the beginning here, no concentrated moment. Your value is 0. I'm looking for moment at this location where point of 0 shear. Okay, your value of moment equal previous value, which is 0, plus area of shear in between. What do you have in between? We have this area. Your value is positive 1/2 times 7.2 times 14.42. Your value will be, so 0.5 times 7.2 times 14.42 will be 51.9. So your value here is 51.9. Keep going. At the end of the distributed load here, what is the value? Your moment equal previous value 51.9 minus area of shear in between. We have this area of shear negative. This one is positive, but the area is negative. Negative 1/2 times 0.8 times 1.58. Your value will be reduced a little bit. So minus 1/2 times 0.8 times 1.58. Your value will be 51.3. At the end of this member, we have concentrated moment. This end related to my position on my right, and we have counterclockwise moment, so it's positive 45. So your value here is 45. Okay, from this point to this point to this point, draw parabola from second order. From this point to this point, draw line based on your shear. Your shear here is a linear relationship. Your moment is parabola of second degree. Your shear here is constant. That means your moment is linear relationship, positive. Last member is the vertical one. What do you have here? This point related to my position on my left. your moment on your left is clockwise, that means it's positive. 45. At the end of this member, no moment and nothing in between. So my value here is 0. Your shear is constant. That means my moment is linear relationship. So here is your normal, shear, and moment diagram for this frame.